Hello everyone, my name's Eric Towers, owner of Towers Arms Custom Gunsmithing up in upstate New York. This is a video for SDI class FTT-122 Introductory to Ballistics. Week 1 assignment: define internal, transitional, external, and terminal ballistics. Internal ballistics is the measurement of a projectile within the weapon. It takes place from ignition until it leaves the barrel. Some interesting facts about internal ballistics: all energy a bullet possesses is gained while still inside the firearm. Any damage to the crown or the crown of the barrel will affect the trajectory. Things that might affect it in flight: the rifling twist rate and the crown of the muzzle. For transitional or intermediate ballistics, the measurement from the muzzle to the point where pressure behind the bullet equalizes. Some interesting facts: the muzzle crown is very important for trajectory. Things that might affect it in flight: unburnt powder and the muzzle crown condition. External ballistics: after the projectile leaves the muzzle until the time it reaches the target. Some interesting facts: the projectile doesn't fly in a straight line. It's called a parabola. It's a curve like a rainbow. What affects flight? There's a lot: gravity, air resistance, wind, shape of the projectile, velocity of the projectile, and the rifling and rotation of the projectile. Terminal ballistics, or wound ballistics: how the projectile behaves when it hits the target. Some interesting facts: projectile creates a temporary cavitation effect created by the high velocity, shape, and composition of the projectile. What might affect terminal ballistic flight? Projectile design, the speed or velocity, and the target material. Part 2 of Week 1 assignment: what is sectional density? It is the ratio of the weight of the cross-section area of the projectile. The larger the sectional density, the deeper the penetration. For example, a 50 BMG is 0.363 pounds per inches squared, and a 9mm is only 0.13 pounds per inches squared. So for part 3, how does a projectile expansion affect the transfer of energy? When a projectile expands, its surface area in contact with a target increases, allowing for more efficient energy transfer. Expansion slows down the projectile, preventing it from penetrating too deep, distributing the energy more efficiently, more evenly. I chose the second question. In the 9mm Luger cartridge, if all else is equal, what would contribute more to felt recoil? A 115 grain, 147 grain projectile, and why? With 9mm, the 147 grain would have less felt recoil. The heavier the projectile, the less felt recoil. For example, 147 grain pushes against the slide for a longer duration, increasing into less felt recoil. The slide is moving slower with a heavier projectile. Thank you for watching. That is everything for Week 1, FTT-122.